So a warm welcome to those as well who didn't hear me yet. My name is Kaisa Amaral. I work at Agora Energiewende. I'm moderating the discussion today, where we present our latest report entitled Ensuring Resilience in Europe's Energy Transition, the Role of EU Clean Tech Manufacturing. I am joined by an esteemed panel of speakers. We have Matthias Buck from Agora Energiewende, our Europe Director. We have Karin Kemetshofer, who is a Senior Project Manager with Roland Berger. We have Martin Hoyer, Senior Associate with Roland Berger. And we have Claudio Baccianti, who is a Senior Associate for EU Sustainable Finance. During these 90 minutes, we will first have introductory remarks by Matthias Buck. Then we have 3 presentations. Our colleagues from Roland Berger present on the results of the analysis that they carried out for us. Then we have a presentation on the public funding side of clean tech manufacturing, and also policy proposals, what needs to happen to ensure resilience in Europe's energy transition and the critical value chains. Without further ado, I hand it over to Matthias Buck with the introduction. We cannot hear
you. Yes, so apologies. So good morning and good day to everyone. It's morning in Brussels, where I'm currently, and perhaps a different time where you are. I will lead you into our webinar this morning, starting with what we will be presenting and why. Can you see my screen? Yeah? Okay. So what's the background to the work that was done? Europe has decided, as other regions in the world have decided, to achieve climate neutrality, meaning no more greenhouse gas emissions across the economy by latest 2050. This requires not only reducing the use of emitting technologies, but replacing currently emitting technologies and processes by non-emitting technologies. In the power sector, this is predominantly solar PV and wind for long-term storage of electricity, but also for some important achievements in the industry transition. We need electrolysers to produce renewable hydrogen from electricity. Heat pumps play an important role both for industry decarbonization as well as for heating of homes with clean electricity. And then, of course, batteries play a very important role in the scaling of electric vehicles, but also as a storage in other parts of the energy system, be it for home storage solutions or other larger storage solutions. So in this picture, you see the ramp-up pathway of clean lead technologies. We're looking at solar PV, wind, electrolysers, heat pumps, batteries. And overall, we see at least a tripling in the case of batteries, even more, multiplication of installed capacity going forward. And here we have shown the installed capacities until 2035. So it's a steep ramp up of clean technologies. Now, this has been on the radar of analysts since we started debating net zero transition pathways for Europe. What has changed since the end of 2019, early 2020, is the political and economic context. We have seen a pandemic. We have seen Russia invading Ukraine. We are currently seeing rising tensions in international trade, particularly between the US and China. And overall, there is a sense that we cannot take, as we've done in the past, the smooth functioning of international clean tech value chains for granted. In addition, China and also the US with the Inflation Reduction Act are now moving much more aggressively on investing into clean tech themselves. So this is putting competitive pressure on Europe's clean transition. So where in the past decade, we always felt Europe was leading and perhaps leading all by itself, will the others follow? Now we're really in a clean transition race, and this increases competition over will we be able to stay ahead. One of the responses by the EU legislator is the so-called Net Zero Industry Act and the Critical Raw Materials Acts. So these are legislative initiatives trying to enhance the resilience of Europe's clean energy transition. Now, what's important in these proposals is that they do include indicative targets for domestic manufacturing of clean technologies in Europe. And because of the rather rushed nature of developing these proposals, there's been little time to do robust analysis under these backing up these indicative targets. And this is what we are trying to support through the study that we published last week and presenting today. So what's the focus of this study? We were commissioning Roland Berger to analyze for select clean technologies, the 5 I was mentioning, relevant value chain dependencies from the raw materials extraction over refining, component production to final products, to find a way to establish minimum shares of domestic manufacturing from a resilience perspective, or like an insurance against value chain risks, and to also quantify relevant additional costs, private or public. On that basis, we then were going a few further steps in analyzing the public funding needs that were resulting from those numbers, place it in context of where we are in the current EU budget situation, current budget, future budgets, and then to develop a policy package that would ensure that public support given for scaling clean tech manufacturing in Europe will also ensure the long-term competitiveness of the sector without support. So I'm handing over to colleagues from Roland Berger. Or Kaiser, you're doing it, no?
Well, thank you very much, Matthias, for the introduction to the topic. And indeed, we move to the presentation. So first we have Karin from Roland Berger, who provides us some more insights on the analysis that they carried out. And then Martin will pick from Karin's presentation. Please, Karin, you can go ahead.
Thank you very much. Martin, do you want to go ahead and share our slides?
Do we have a technical issue, perhaps? I think.
Okay, so I will just start with the presentation, and we will just pick up with the slides when they arrive. Thank you very much for the introduction. So we set out, as Matthias presented, to basically find out what the level of resilience could or should be within Europe, and we did this by firstly looking into the different clean tech technologies, starting from PV, going into wind, onshore, offshore, electrolyzer, heat pump, and then into the batteries. Looked into how their current status within the European production setup is looking like, and then looked into different scenarios. So what the shape could be when looking into raising or decreasing different levels of resilience. So starting out with a view on the current geographic spread within the production setup, which is on the page 5 of our document, if you could jump there. we see on the Thank you very much. So we see on the left side of this page the current geographical concentration. And what is striking when you look at this admittedly rather colorful picture is that we do see certain concentration patterns, meaning that we do have a historic focus of European production on the southern, northern, and western parts of Europe. Specifically, this comes through when you look at wind production in Spain, for example, and other production areas, for example, with heat pumps that are rather on the Western and Central European focus. There is some production also in the eastern parts of Europe. However, historically speaking, not so much as one could expect. What this translates to at a global market share perspective is that from a PV, basically two different pictures. The first picture, when you look at, for example, PV, is a rather low global market share. And then looking into other technologies such as wind, electrolyzer, and heat pumps, this raises up to 16 to 26% from a global perspective. When we look at Europe on the next page, you can see the spread of the European production as part of the European demand across the different technologies and components. And what we can see here is the picture that we saw on the global level, also transcending at a European level, having PV with comparably low local demand share, reaching up to 28% for modules, and then also from a battery perspective on the right side of the page, also only 12 to 50% for LFP and NMC technologies. In the middle of the picture, we have the technologies with a higher current capture rate of demand, specifically high for wind offshore as well as wind onshore, up to more than 100% of what's currently demanded in the European market. And then from the electrolyzer perspective, with the AWE above what is currently demanded, and PEM technologies, so the proton exchange membrane technologies, getting up to 64%, with heat pumps then up to 80%. What does this leave us with? This leaves us with the view of a very dispersed view of the current setup, with asset PV at the local, at a very local level, and then wind with a higher level. Now, we'd like to drill down a bit more into the supply chain, into the underlying supply chain. And on the next page, we're going to focus on the gray areas of the presentation. Moving on to the supply perspective, we have basically a threefold split. What we can see is we have higher range, medium range, and low range material views. And what we did here was looking into how much of the production of the European production can actually be, from a raw material perspective, also produced, meaning sourced, and meaning extracted and processed. And what you can see here when you focus on the gray little dots on top is a spread. It's a very interesting spread, and basically an indication of two challenges. So the first challenge in the dark gray box says that there is demand for this specific raw material that's above of what can currently be extracted and processed in Europe. And then in the currently white shaded box, you see no extraction, which means that we have a certain amount of raw materials that are needed for the green technologies that are not currently not extracted at all within Europe. And that leaves us with an issue specifically for three technologies, and that is wind, batteries, and electrolyzers, which do highly depend on raw materials such as rare earth elements, as well as platinum group elements and other elements that we're currently either lacking or not producing / extracting within European borders. What does this mean more specifically on a technology level? If we move on to the next page, we can see that when we spread out the technologies, and what we did here looking into material intensity, so how much of a material do you need per gigawatt or gigawatt hour of production, you can see that is a bit of a fairly spread view. The first view that we have, or the first material that we look into from a PV perspective, is silicon. Now, we do have silicon production or silicon sand production in Europe. However, polysilicon, which is the key input for wafers, is currently not sufficiently done in Europe, which makes this highly import reliant. For wind, as previously mentioned, we have this the span of rare earth elements that go into permanent magnets. Permanent magnets are used for wind offshore. And as said before, we are highly import reliant when it comes to these permanent magnets. Other materials such as manganese, nickel, and molybdenum are also used across various components and parts throughout wind offshore and onshore. Now, if we just remember nickel here for a moment, and I'll go through the our other technologies, we also have a high nickel demand for electrolyzer, a nickel demand in heat pumps, and also a nickel demand in batteries. So that is one of the challenges that we have next to just sourcing it for one technology. Obviously, we have multiple technologies needing a similar or the same kind of raw materials, which further increases the pressure that's put on the different producers of these technologies to make sure that their supply chains are intact and they can source them successfully. Other raw materials that do pose a challenge throughout these green technologies are, for example, as already mentioned, platinum group materials used in electrolysers, as well as lithium and cobalt, looked as they are needed within the battery production. Now, I have spent some time raising questions about where do we get these raw materials, and that's the next step that we took. We looked into where do these raw materials come from. And on the next page, bear with me. I know it's, again, colorful, and I know it's a lot of information. However, let's just blend out the colors for a second and focus on the dark green shades for the extraction and for the processing perspective. What we can see when you just focus on the dark green shades is China. China is one of the leaders in extracting the key raw materials needed within our green technologies. But they're not only leaders from an extraction perspective, because you can see if you now open up your mind towards some of the other colors, for example, focusing on orange, which is Australia, extraction, that happens globally at a certain range. If we now focus again on green and look into processing, here is where the real challenge is coming from, meaning processing capacities, refining capacities that are for some materials up to 100% located in China, which basically renders a high import reliance or an absolute import reliance for these important raw materials, specifically, for example, for the rare earth elements that are used in permanent magnets, and make diversification a challenge, which also in the next, and this is something that we're going to see further on, China is an important player within this processing stage. Now, obviously, this is the world view, so one might ask, so what happens now in Europe? And that's the next page, if we move on, which is the flip coin from the European perspective. Again, colorful, however, as you can see, bit of different colors. Why is that? So from both an extraction processing perspective, we have two factors. The first factor is that there are some raw materials, as previously mentioned, that we can extract within Europe, and which is obviously also done at this point point in time. And then we have a certain degree of diversification when it comes to processing. However, so again, we remember green was the color that China was very, very prominent and very vivid on the world perspective. It's not as vivid here at first glance. However, and here comes the challenge, while processing goes into various stages. So the preliminary or the first stages of processing, they very likely still remained in China. So while Europe is not sourcing directly from China, we're still reliant on the initial processing and refining capacities and capabilities. So coming up, we're basically closing this first part of the analysis. Key takeaway here is that while there is certain diversification, the challenge remains what kind of partnerships or how can you partner up within your supply chain to make sure that you really have access to what is needed in order to produce locally within European borders. And that's the next part. And being mindful of time, I'm going to run through this with the same pace. Supply scenarios. As previously mentioned, we looked into supply scenarios from a resilience perspective. So on the next page, very briefly, resilience, there are 3 different sides to resilience, and we predominantly looked into the domestic manufacturing, not so much into circularity and the international supply diversification, as I have mentioned before. From a calculation perspective, quantification perspective, we focused on domestic manufacturing as our focus for resilience. So how do we define resilience? We define resilience on the next page as our ability to mitigate risks to the overall European market derived from the dependency on imports into the EU. We did this, so basically our resilience level is based on a risk assessment score. And how did we do that? We assessed our risks based on 5 different categories, from economic, geopolitical, technological, geographic, and digital risks, including a wide span of different risk factors, such as coming from demand to supply gap towards digital malfunctions. Now, where does this leave us? When we look into on the next page, on the results, so as said before, we have our different risks, but I will jump over to the results. And what you see here is very briefly the result of the risk assessment. So if I just pick PV as one example, what you can see here is that for the 3 components, wafer, the silicon cell, and the modules, what our risk assessment yielded in what should be the capture rate, what should be the European production, the share of European production for these different components, and we get between 50 and 55%. What you see in addition are those dark gray lines. These are the NZIA market share targets, so preliminary targets that were indicated by the European Union. And what I would just like to point out is that for PV, we are even above that target. However, for the other technologies, our analyses yielded a lower share that was indicated by the European Union. And this, as said before, is based on our risk assessment on component level. Now, if we move on to the next page, just very briefly, and Claudio will spend more time talking about the different scenarios. We looked and quantified from a base case into basically are focusing on 2 different scenarios. One, the EU optimized, and the other, the country optimized. What's the difference? From an EU optimized perspective, we're really focused on allocating based on what could be the competitive or comparative advantage between the different countries from, for example, energy cost perspective or labor cost perspective, which was the driving allocation factor for potential production. Compared to that, the country optimization, looking into which countries currently have interest and show interest into further developing their European manufacturing base. So having this in mind, we go to the last page of the presentation, and drawing back the circle again with our colorful slide. Remember when we said our current or our status quo is focusing on the on Western, Southern, Northern Europe. Now, when we look into the results of our analysis, we basically see 2 things. If we go via an optimized or an basically unit manufacturing cost optimization scenario, we would be focusing on Southern and Eastern Europe, basically Southern Europe by focusing on cheap energy, and Eastern Europe leveraging competitive labor costs. Now, when we look into the country optimized scenario, one basically can draw the conclusion that countries that currently already have a strong production footprint also in this scenario would be the focused receivers of that kind of allocation. And so that is basically summing up the results of our analyses. And I'm happy to hand over back to Matthias and Claudio for the policy implications.
Thank you, Karin, and good to see you back, Martin. Technical issues are always present when you do webinars, but so thank you very much, Karin, for a very detailed but also very clear presentation on the assessment that you did on the Roland Berger side. And now, as Karin mentioned, we're going to move on to the other part, where Claudia Baccianti will start by walking us through the public funding needs that are, of course, linked to scaling EU clean tech manufacturing. And then after Claudia, Matthias will also have a closer look at the policy package that would be needed to facilitate this scaling of EU manufacturing. Thank you, and over to you, Claudia.
Thank you, Kaisa. Can you please move one slide forward? Thank you. So we'll pick up where what already has been discussed by Karin. That is the in different scenarios, what are the minimum shares of EU manufacturing capacity that result from the risk assessment, and here especially I want to show there was not in the current slide, is that you can see from the result of the risk assessments that the recommended levels are around 50% for the different technologies, but the starting point is very different. And what is especially important in terms of for the public funding needs is exactly the gap that has to be filled. And so you see here that the PV, for PV we are starting from very low levels, so there is a large gap to be filled. And also for batteries, there is a gap that is smaller, but what's important for batteries is that it's currently a small market that will have to expand massively in the future. So this will impact also the funding requirements, the fact that this market will increase exponentially over the next years. Next slide, please. So these investments will not happen unless there is a right there is a right policy framework in place. Okay. Yes, thank you. And so the right policy framework includes public funding, and this is because, especially for technologies like solar and batteries, there is a structural cost disadvantage of EU manufacturers. And therefore, this is the lesson we also learned from the Inflation Reduction Act. An important element of the policy mix is having funding, especially of the non-repayable type. So OPEX and CAPEX support. And the first starting point to understand how much this is going to cost, because there's been, as Matthias mentioned earlier, there's been quite a lot of debate, but rarely we see an estimate of how much will be the public funding needs to achieve this given levels of EU manufacturing capacities. So the starting point is to know what's the size of these required investments. Okay, so we start from the analysis of Roland Berger, and I briefly here just show the aggregate numbers, so the cumulative numbers in different scenarios. And I want to, so these numbers include both the public and private spending needs that I will unpack later on. So This is how much spending in terms of OPEX and CAPEX will be needed to reach the minimum level of EU domestic capacity that the different scenarios project. And so you see that this is, of course, the costs are increasing in the level of ambition. So in the Net Zero Industry Act scenario, with a higher level of domestic capacity, we have higher costs. And also what's important is that you can see that OPEX dominates in terms of cost, the share of cost. So CAPEX and reinvestments are like a follow-up of CAPEX. So CAPEX per se, it's a relatively minor share of the total cost, and OPEX dominates. And this has implications for the public funding requirements. So based on these numbers of the database that was provided to us by Roland Berger, we calculate the public funding needs. And I will briefly go through the methodology. Please, next slide. Yes. So the procedure is basically to split this cost between the public and private sectors, and then between the EU and member states. So let's first look into the split between public and private. So the main rationale here is that there is a structural cost disadvantage of EU manufacturers that has to be filled, or kind of filled and then supporting this gap closes in the future. And so we observed that across different technologies, there are quite substantial cost disadvantages that can go up to a third of the cost compared, for instance, to leading Chinese producers. And so you see in this table that for CAPEX, we apply some standard support rates that we already see, for instance, in existing support schemes. But what's more, let's say, new, especially in Europe, is the OPEX support. And so there we really look into these cost disadvantages in terms of labor cost and energy cost, and apply support rates that are closing this kind of cost disadvantage. And we will assume that later on, at the end of the decade, these support rates will decline. Okay, so then there is the point of how to split between the cost between EU and member states. This is an important element, and for that, this is a purely political. At the end, it will be a political decision, but we think that, as it was already implied by the scenarios in the EU coordinated case, we have there are advantages to have a more centralized EU funding instrument. Okay, so there we have you see here the numbers. The first number before the slash is correspond to the share of EU funding in the EU coordinated scenario, and the second number after the slash is in the national driven scenario. So then I will now talk about the results, what we get. So we find that, let's start from the EU level, okay? Because this is the most critical point, I think. So that achieving the minimum shares of EU manufacturing in the EU coordinated scenario or nationally driven scenario. So what results from our risk assessment is is between 10 and 30 billion euros until 2027. and 2027 is the end of the current EU budget period. And then in the next EU budget period, from 28 to 2034, the public funding requirements at the EU level will triple. And this is mostly due to the fact that, as I said earlier, that the PV industry has to catch up, and the market for batteries will increase exponentially. So this is really an impact on the cost. And again, I'm talking about here about only non-repayable support, what's called subsidies, so not loans. Okay, this is not part of this calculation, because loans is not really effective to address structural cost disadvantages, and also at the end it would be cost. This would be repaid by the private sector, so are actually part of the share of the private sector, accounting for a small subsidy on the borrowing cost. Then this will be, you can see, this will be a challenge for the next EU budget, because if the EU is serious about pursuing this goal, then more funding will have to be made available over the next in the next EU budget period. In both cases, whether this is more, the EU chooses to centralize the support and then have an instrument more like the EU Innovation Fund that gives money to all member states, or a downscaled version that instead is more focused on supporting the member states and regions in need. And next slide, please. Then the counterpart of this is the national public funding needs. Then here, what I want to highlight is the split between the Western and Eastern EU and the Central and Eastern European countries. And you can see that there is a quite even split, but given that the Central and Eastern European countries have a lower GDP, this will have an impact, more of an impact in this region. And if we sum up the national and EU public funding needs, we get a number of between 164 and 180 billion euros in cumulative terms in the two scenarios. That is, interestingly, this is around 1% of GDP in cumulative terms, and this is roughly what has been estimated by Credit Suisse for the Inflation Reduction Act in terms of manufacturing support by 2032 in terms of the size of GDP. So what we calculate is kind of in a similar amount in terms of percent of GDP. Then let me conclude with the final slide, where I want to put these numbers into broader perspective. And the broader perspective is to take into account of the costs of the public funding requirements for the deployment of clean tech. And this clean tech deployment will actually have much larger public funding requirements at national level, even if we take into account of the support that we receive from the EU. So this chart really focuses on the public funding needs at national level, and you see the kind of greenish bars. This is really the clean tech deployment public funding needs net of the EU support. And for the EU funding data, you can check on our website, we have a EU climate funding tracker with details for different member states. And the main takeaway from this chart is that in Southern EU and Western EU, then we don't, like the clean tech manufacturing public funding requirements are relatively small compared to the to the deployment side, but this is a different story for the Central and Eastern EU, where they are relatively more supported on the deployment side from the EU, and then they will have more higher funding requirements for clean tech manufacturing, as they are an attractive area for instance, for the battery industry. So this, then I hand over to Matthias to continue, or to Kaiser.
Thank you, Claudio, and I just add some reflections on top of the public funding. So just to recall what the analysis was about, it was about the minimum shares, really, that we consider in insurance against value chain risks. And this insurance would add to the resilience of Europe's clean tech transition. And for Kimitsofa already showed our conceptual thinking of resilience. So for us, this is just one part. The domestic manufacturing is just one part of enhancing resilience. Other elements will add to increasing the resilience, including international partnerships, supply diversification, circularity policy, substitution, which is closely linked to innovation. And you will see these also different elements that we have woven into the policy package that we see as necessary to complement the Net Zero Industry Act and the Critical Raw Materials Act. So what we are offering is ideas that would complement what's currently on the legislative table. And as was shown by Claudio, the key challenge, and this really results from the analysis of Roland Berger, is there is a structural, at the moment, a structural cost disadvantage of producing leading clean technologies in Europe, related to energy costs, labor costs, and other cost factors. And this, if we are serious about increasing resilience through scaling domestic manufacturing, we need to address this. At the same time, public funding, of course, cannot be given forever. And this is why we consider it needs to become part of a package. Now, where the EU legislator is currently working on is on indicative targets, accelerated permitting, all these kind of things that would, from a regulatory side, facilitate the siting, the production. There is insufficient political commitment at the moment on the public funding challenge that needs to be addressed really to scale the domestic manufacturing of clean technologies in Europe. So for this, to give this visibility, we consider we will need a distinct public funding commitment. And this for this reason, we propose that the Commission should establish or propose to establish a clean tech manufacturing fund, explicitly with a mandate of closing the OPEX and CAPEX cost gaps. This is, as Claudio was shown, less of a political challenge or funding challenge in this current budget period, but it is a really important political and funding challenge in the next EU budget period, which will start in 2028. And discussions on the next EU budget will start, of course, much earlier, so latest in 2026. And by that time, we need to have the political commitment to give the forward visibility of public funding availability to the investors that we want to attract to Europe to scale clean tech manufacturing. Now, how to ensure that there are stable revenues for the fund? We are offering two options in the paper, which we call a clean tech manufacturing contribution. But this option one would be earmarking a share of national ETS revenues. This is something currently also being discussed. I just saw yesterday in the council. And another idea links to a raw material contribution linked to the greenhouse gas intensity of products put on the European market. There is a whole literature on that option, and it is clearly linked to Europe's commitment to increase the role of green product standards going forward in the establishment of clean lead markets, which is also really at the heart of the green transition. I want to focus a bit more on the other elements: privileged access to variable investment finance cost. Of course, this is important. There is a whole range of investment and finance support instruments out there from national development banks, from the European Investment Bank. I will not go in here. The overall objective is to shorten the payback periods of investments in new manufacturing sites and to also enable larger scale investments. This is something which we see should really become like a plug and play system. So if a project qualifies as a net zero strategic project, it should quasi-automatically get access to these privileged financing conditions. Another very important point is that, particularly in order to reduce support need going forward, that we would see the support given today to clean tech manufacturing in Europe linked to a commitment to really achieve the highest standards of sustainability for the clean technologies manufactured in Europe. So that the European clean tech production would be at the top end of sustainability worldwide. This would then, in the next element, element 5, also facilitate linking long-term demand for such products, at least in Europe, through public procurement instruments, through some other instruments where, for instance, private households are supported to purchase certain support to purchase electric vehicles, or building renovation support, to then link it directly to some clear criteria also on the sustainability of the clean tech products being purchased. And this would reduce international trade frictions because it can be done in a non-discriminatory way. And it very closely links to the need to scale green lead markets. And of course, when we think about green lead markets, we do believe that European manufacturers should be really in the middle of those clean lead markets and helping to lead the way. We also consider, and this I think goes to the very beginning of the presentation when Karin from Roland Berger was showing the very high dependency that we currently have in Europe on some of the leading clean tech suppliers, which are much better than European manufacturers at the moment, managing the full value chain from the raw materials over refining to component manufacturing, that we in Europe have an interest to be attractive for such players to establish manufacturing capacity in Europe. And of course, this means collaborating with companies from countries where there is currently a very high dependency. Now, we consider this is important because de-risking or decoupling, as some refer to it, is important, but this cannot be done overnight. What is important is to scale manufacturing in Europe, but also at the same time be conscious of the need to do a gradual de-risking of value chain dependencies. And this can be achieved through certain safeguards, long-term, to ensure the long-term commitment of the clean tech manufacturers from overseas when they establish production in Europe. Last point on innovation. This is, of course, very important to continually innovate, also to address some of the other elements of resilience, namely the substitution of some of the elements, raw materials, where there's currently very high dependency. For instance, cobalt is one material in one case in point where the substitution could reduce some of the current dependencies that we have in the relevant value chains. So this is the full package of measures that we are proposing, that we recommend to be developed complementary to the Net Zero Industry Act and the Critical Raw Materials Act. And this is concluding the overall presentation. I will not, Kaiser, now go through this again, but just leave it for everybody in the webinar to see, because it's just rehearsing what we already said. Over to you, Kaiser, and I hope we have a good Q&A.
Okay, thank you very much also, Claudio and Matthias. We would now have time for questions and answers. However, I see none in the Q&A box. This is your chance. I also think that the presentations were great, but we have all the experts on clean tech and critical value chains here to take any of the questions that you might have. So please go ahead if you still have any clarifying questions or you have a comment that you want to share with the panelists. And I will give that another minute if you need. And I would maybe just ask one question as I was looking at Claudio's presentation. When we look at the different costs between a nationally driven and EU coordinated approach, and it seemed like there's quite a big difference in terms of how much cost there will be. So would you, at least to me, I'd be interested to know, elaborate a little bit more on like what do we mean by EU coordinated and nationally driven?
Yes, thank you, Kaiser. This is an important point. And so in the EU coordinated scenario, it's a scenario where the allocation of the funding is done at centralized level, at the EU level. And this has the benefit of letting the support scheme pick the best locations in Europe. And the alternative way is the opposite way. In the nationally driven scenario is a bottom-up situation where the support is completely driven by member states, and each of them want to attract plants, manufacturing plants. And this not only leads to a subsidy race, let's say, but it also has the problem that there might be redundancies and too many plants are built. And why is it a problem? Because in some sectors like solar PV, but also batteries, economies of scale are pretty important. So therefore, here, Europe, given the importance of economies of scale, it's important that Europe takes a common approach and tries to really support some European champions. And if we have the number in the paper that if you look at the data, for instance, in solar PV manufacturing in China, the plants are much larger than the plants we have now in Europe. So the size is really important. And this is reflected also in the costs.
Thank you very much. Okay, maybe I ask a follow-up question. The Net Zero Industry Act targets in some areas are much, much higher than what we assessed in this one. What would be, why is that? And who would like to help me with this answer? Would it be Karin?
Well, if you know, I can take that one.
Okay, Matthias, sorry.
Yeah. So this actually, I think it's important to, because this was also, we had quite some extensive discussion on this also in the team. What are the different targets and how do they compare? In the Net Zero Industry Act, there are some indicative manufacturing targets, and Karin was showing them, and Claudia as well. They are in part for batteries, for wind, significantly higher than the result of the quantitative structured risk analysis would suggest. And how do you explain the difference? Now, the difference, I believe, simply comes from the different methodology applied, so to speak. In the Roland Berger analysis, the focus really was on the risks in the value chains and trying to quantify how this could, the risks be mitigated, so like in insurance, through domestic manufacturing. What are the resulting levels? And so from that perspective, the outcome of the calculations and the work really is like an insurance for Europe to be on the safe side. What's in the proposals in the Net Zero Industry Act is the result really of a dialogue between the European Commission and the industrial associations for the different sectors. And so kind of includes more elements also linked to maintaining world market competitiveness. This is particularly important for the wind industry, for instance, maintaining some of the currently existing jobs in Europe and some other thinking. For instance, I know that in the battery, where the indicative target is much higher than suggested by the risk, from a pure risk perspective, of course, this also links to the broader automobile value chain, where Europe is currently at high risk of losing some of its automobile industry because we're really lagging behind when it comes to electric vehicle manufacturing. So it's I think it's important to show these different methodologies. What we are offering really is an insurance perspective on what should be minimum shares from that perspective.
Thank you, Matthias. And very nice. I see questions coming in also from the audience as we speak. Okay, there is a question. Money is interesting always, and more questions about the funds. So, Claudio, I will give you this one. Have you also assessed where the funds would go to? What are the areas that would require them the most? Infrastructure, education?
Yeah, so we looked at the geographical distribution, as I showed earlier, based on the Roland Berger's analysis. But in terms of broader spending needs, like infrastructures and education to train the workforce, we have not really looked into that. So this would be additional. There will be additional spending needs to what we have previously shown. But I would say that, just let me add that, okay, there is infrastructures can pose like a challenge in terms of funding, definitely, but in terms of other investments like education, what we learned, for instance, from studies about clean tech deployment is that this is at the end a relatively small spending item for governments.
Then we have a question on the analysis by Roland Berger. I will read it out loud. In the first slide, a required electrolyzer capacity of 34 gigawatts by 2030 is stated. If only 34 gigawatts would be installed by 2030, a huge waste of excess renewable electricity would be the result. If, for instance, twice the capacity would be installed, the loss would be much lower. So the question is, why only 34 gigawatts in 2030?
That's also Charles, I believe. I mean, Charles, you want to say it? No.
Actually, I was going to refer back to Matthias because this is an Agora study.
Okay.
So we have, as you may know, if you have not read it, I warmly recommend reading it. We have done a quantitative analysis on the cost-effective transition pathway towards net zero. And specifically, in that the 2030 waypoint for electrolyzer installed capacity in 2030 is 34 gigawatts. This is significantly below what the Repower EU plan foresees. But as you may be aware, there's also currently a revisiting of some of the very, very optimistic assumptions the European Commission had at the time of the Repower package on how fast renewable hydrogen production in Europe could be scaled. So at the moment, what I hear is that our number is actually fairly robust, very closely links to also what the market shows will be projects that get the final investing decision within Europe if the public funding commitment is there. And of course, specifically for renewable hydrogen, the Commission has established the Hydrogen Bank. So there will be public funding going forward, as well as from national level.
All right, thank you. And indeed, questions are coming in. I have a question directly addressed to Claudio. Recently, Mayor Berger's solar PV manufacturer in Germany claimed that beyond a 2 gigawatt production capacity, no more any economy of scale effect can be realized. Upscaling amongst CN solar manufacturer is not driven by economy of scale considerations, but rather by egos. Furthermore, even if EU member states offer subsidies in order to attract investments in clean tech technology production, if there is no industrial ecosystem existing, attractiveness is still rather low. However, as I finish reading it, I don't actually see a question in there. So maybe you want to follow up and formulate a question, but the comment is duly...
Let me just say that, I mean, given that the current state of the EU solar industry, is hard to claim that you cannot achieve more economies of scale. And this is also, I mean, the role of economies of scale, I mean, is pretty documented by studies. We can discuss to which level of gigawatts, but I think it's an important point. And then it's true that China in the past is giving a lot of subsidies. So subsidies are a factor, but then the result was also these economies of scale. And now we have to deal with these economies of scale they have. And the subsidy they gave in the past, well, is a thing of the past.
Thank you, Claudio. Okay, and then we have a question on macroeconomic risks. I would also be interested in your assessment of macroeconomic risks, interest rates, investor confidence, economic growth. Have they been taken into account in the scenarios? Who will take this one?
But I don't know, probably for Christopher, if you want to explain how, I think that it's a kind of cuts across both, no?
Yeah, exactly. So I can reflect on what we did in our work, what were key input parameters. So for the quantification that we did look into inflation rate, for example, inflation rate on a country level that impacts the analyses. We also looked into discount factors, so forecast, 10-year bond forecast on country level in order to discount appropriately. So this is the extent of the macroeconomic environments that we included within the model. And then throughout the other assessments that we did, we obviously also looked into influencing factors. So for example, for the resilience level, we looked into risk factors which touch upon macroeconomic developments, such as political risks, etc.
Anyone want to comment on that, or shall we move on? We have more questions. I'll take the next one. And I think this could go to Martin, actually. We also hear from you today. after all the technical issues. So a question, with a lot of startups and research in the clean tech market, did you consider changes in the applied technologies? Which sectors are likely to change the most in the coming years with new technologies? And what are some of the upcoming technologies that are most likely to enter the market?
Yeah, thank you very much. So for the study, or maybe first of all, to the question, then the derivation to the study, I think there are manifold potential ahead of us when it comes to leapfrogging the technologies of today, especially when we look at PV. There, the largest efficiency step is still ahead of us. Same for battery. So we strongly believe that let's say the force of innovation will be pivotal in order to increase the efficiency of the system in the future. That having said, we also believe that with regard to 2030, it is important to concentrate on what is here today in order to increase resilience and reliability and economics in the short run. So therefore, we really have focused on the cost levels that we can currently see, not taking into account too much cost effects from innovation, while not neglecting innovation. But we don't want it, or we didn't want to build the house for that concept based on the pillars of innovation that has not taken place yet. So that's basically the mindset of the analysis, just in order to make it really solid, give it a solid foundation, and make it really robust and actionable.
Kajsa, if I may compliment on that,
please go ahead.
I think it's also from a political perspective, the legislative proposal on the table includes an annex where you have a list of so-called net zero strategic technologies. And while there's a lot of debate about, keeping options open, technology neutrality, very clearly, we know some of the lead technologies that will rapidly reduce emissions because they are the best investment going forward. And this is solar PV, wind, heat pumps, electrolysers, batteries. So this is very clear. This will not change. What will, of course, change is the specific capacities, the costs per unit of production will come down, the efficiencies will increase. There may be some technological breakthroughs, substitutions, innovations happening in those lead technologies as well. But very clearly, it's important at this point to prioritize and to really focus and zoom in on scaling fast what we know will reduce emissions very rapidly, could reduce emissions rapidly. And so it's important, of course, to innovate and also not lose sight of potential new technological solutions coming up that could help reduce greenhouse gas emissions very fast. But in this study, we're really focusing on the ecosystem of scaling what we know works, and to really make it as cost effective and also future cost competitive within Europe as possible.
Very good. I don't see any more open questions at the moment. We still have a few minutes. If anyone has something that they still want to ask, please go ahead. Doesn't seem like it, so I will still hand over to Matthias for a few concluding remarks after this session.
Yes, thank you for this. And first, thank you to colleagues which have contributed to the webinar, and to our colleagues from Roland Berger who put so much work into the analysis that we could then really build on for some additional reflections, particularly on the policy implications of the analysis. I can warmly advise to go through the very comprehensive slide deck by Roland Berger colleagues that is available on our website. I also, of course, warmly recommend the report that we have written on the basis of the analysis. And everything that we have shown today will be available on our Agora website. And so please get in touch with us if you have additional questions that come up reading those publications. We are very, very happy to discuss, stay in touch, and help advance the knowledge on what works and will do good for all of us. So I don't know. Those are my closing words, Kajsa. There's not so much more.
Very good, very good. Well, we already covered kind of the substance conclusions anyway from this event. So I would also just like to thank everyone for my part, our esteemed speakers today, also the audience for sending in those questions.